So in these examples, what we're asked to do is actually find the inverse of a function. So first, the function has to be one-to-one to even have an inverse. This function is a one-to-one function. We see the graph over here. It is a line, and all lines except for horizontal and vertical lines are functions or one-to-one functions. So I don't know if I said that correctly. So a vertical line is not even a function. A horizontal line is a function, but it's not one-to-one. All right, but this is not horizontal, nor is it vertical, so it does have an inverse. So to find an inverse, we're going to follow this step-by-step process. We did one of these in class, but I'm going to back up and do it number 10. So first, we're going to replace f of x with y, just so we can work with it algebraically. Then what we're going to do is interchange our x's and y's. So wherever there was an x, I'm going to put a y, and wherever there was a y, I'm going to put an x. Step 3 is now we need to solve for y because we usually write our functions and name them with function notation, but we have to solve for y before we do that. So what we want to do is get everything that doesn't have y in it on one side and everything that has y in it on another side. So I'm going to subtract 2 from both sides because this 2 term does not have y in it. And I'm going to go ahead and flip this around because I like what I'm solving for on the left. So I'm going to write this as 1/2 y is equal to x minus 2. So this canceled. I'm left with x minus 2, and I'm going to put this over here, and 1/2 y, and I put it over here. Now, you don't have to flip it around if you don't want to, but I'm a little OCD, so I like what I'm solving for on the left. All right, so now I need to solve for y, so I need to get rid of this 2. So I'm going to, get rid of this 1/2. So I'm going to multiply both sides by 2. So 2 times 1/2 is just equal to y. But I have to multiply this entire side by 2, which means I need to distribute that 2 to both terms. So that's going to give me 2x minus 4. So now I'm going to name it with what it was. So this is the inverse. So now I'm going to name this f inverse of x then is equal to 2x minus 4. So I was asked to write an equation for the inverse, so I just did that. Now I want to find the domain and range for the original function and its inverse. Well, the original function was a line, and if we look over here, the domain of the original function is going to be all real numbers. The domain of the inverse, without even graphing it, there are no radicals, there are no fractions here, so the domain of the inverse is also all real numbers. And you may be saying, well, wait a minute, Miss Murphy, this one has a fraction, but remember, it's x that can't be in the denominator of a fraction. So the fraction in this function is just a coefficient. X is not in the denominator. And if we let x be 0, the value of the function would be 2, and that's defined. So don't get fooled by coefficient fractions. Those are okay. And then it wants me to, so the domain of both of these is all real numbers. Then it wants me to graph the inverse. So the inverse, remember, is a line. If we look at this, think of it as y equals mx plus b. Where b is equal to -4 and m is equal to 2. So remember, we can graph a line by finding its y-intercept, which is -4. So I can plot that point there. And then from there, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So here is the graph of the inverse. And if you remember, all graphs of an inverse of a function is the reflection over the line y equals x. So that green line is y equals x. So you can see that the blue line has been reflected across the green line. And so the blue line is the given function, and the red line is the inverse of that function. And that's it.